each time we go into a lesson, what we will do is we've got three parts of it. So there'll be the class lecture discussion, and that's going to be learning through listening and hearing and seeing, but not note taking. Because when you're note taking, remember the way the brain works, you're translating things into language, into written words, and there's a lot going on in that process that gets you away from what we're doing is really doing a story. So it's like storytelling. We're learning the content through just listening to it. And yes, we're going to forget something. One of the elders I learned from, they said, and from their tribe, they when you write something down, that's the beginning of forgetting. Think about that. When you write something down, you can forget about it because it's on that piece of paper, right? But if you lose that piece of paper, there's your memory. So it's important to learn how to remember things without having it written, just knowing where it is in your mind. So we're going to focus on doing that for this first part. And we'll get the whole overview picture, and don't worry about the details. I can't remember what that word means. What we're going to do then is in the second part, um, we'll give you this blank note sheet, which we've got them printed out for you. Uh, so they'll have places, and there's places to fill in, and some of the vocabulary we're doing, it's all there. And there's a textbook. This one is directly related to the textbook. So when we pull up the textbook, there's highlighted parts that gives you those definitions too. So then you switch your learning from more of an academic side of looking at written text, thinking of it, talking with your neighbors as well, matching those things up, and then writing it. So you're dealing specifically in an academic mode, okay? And that's going to build that kind of memory, which is different than the memory we get from just listening and focusing there. Some of us are more into oral type stuff where we listen and we remember. I've always done that. I'm into music and such. My brother, he's different from me. He sees things written and he remembers them that way. So we're going to work through that. And then what you're going to see is that in the resources, not only is there a textbook that has all the stuff written down and you're kind of matching and going through there, there is a completed note sheet. So when you're done, you can check it. You can see, did I get everything, quote, right? Now, sometimes your answer is going to be a little different or something, but you have that backup, right? So you're kind of doing this in two steps. You're going through, seeing how much you remembered from the storytelling time, how much you match up with that in the textbook, and then you have a way to check just to make sure. Because if we get something wrong, like I did when I was a kid, sometimes I'd remember some facts really well, but I remembered them wrong and I didn't get them fixed till later, and you can't unremember them. So right when you learn them and you say, oh wait, I had those two mixed up, you'll be able to deal with that, and then you're going good. And then at the end, there's one homework for all of chapter one. We're going to do it in maybe 4 different sections. So then it says you can remember. I think I showed you those. There's 44 questions in the homework. After today, we'll be able to do the first 22 questions, 1 through 22. So then we'll work on those, and then we'll move on to 1.2, and we'll do it again. Okay, so a presentation, kind of get the overview of everything, then doing some note parts, working together collaboratively, talking about it, reading about it, doing it, and then using those notes to work through the homework, which are going to be similar type questions. Okay. And then when we go through all of that, at the end, there's going to be a written quiz. So once these are all completed, you'll have those to go back and kind of see what happened in the whole chapter, because we'll do it piece by piece in 4 pieces. At the end, you want to put it all together. So you'll do that. And then there's also a homework quiz. Once we finished everything, you go through that. And they're not like tests where you have to get it right or wrong. You're going to see if you put in the wrong answer, it will tell you it's wrong. So you get a second chance at it. If you get it wrong again, you can ask for another question, because 2 times you got it wrong. You okay, what's going on here? Ask somebody. So we're going to get you through. But that quiz is kind of going to bring all the whole chapter together for you. Okay, kind of prepare. And then we go to chapter 2, and we do, I think, 2 or 3 chapters, and then we'll have a test on that. So it's just kind of learning in steps, doing some work on it, reviewing it, and then testing so that you actually know how to do it. Okay, all good? All right. So we're going to start off with this, and see how this all works. This is going good. And again, I'm taking, since the other school is using a Pearson product, I'm using their PowerPoints to get this together. And again, remember, this is just, don't worry about notes. In fact, actually, if after we try this once and you say, I really need to take some notes, I don't ever tell anyone, don't do something. You know what works best for you, but try this. No notes, just kind of listen as we get this overview. So these are the types of things we're going to look at. We're going to look at what statistics is. We've talked a little bit. We're going to be able to tell the difference between a population. Can't get too far from here sometimes. The difference between a population and a sample. So those are the bolded words that we're going to be using. We're also going to be looking at what does it mean to be a parameter or a statistic. And then we're looking at there's two types of statistics. I've mentioned a little bit before, but we'll get into the details of what's the difference between descriptive versus inferential that you can find out about. Okay, so what is data? It's information that comes from observations, watching things. We count things, we measure things, and sometimes we ask people their opinions and we write those down. So we collect people's opinions or something. So all those things constitute what we would call data. Maybe something like 7 in 10 Americans believe arts unify their communities. So again, it's an opinion, but then we count how many people had that opinion, right? Maybe 2 out of 5 Americans changed their opinion based on an arts experience. So this is from a source, American for the Arts. So they go around, how does art affect you? So data, right? What people think in numbers. A lot of times we look at things as percentages. 21% of 8 to 11-year-olds have a social media account. So somebody had to go out and count how many did and how many didn't, and then we can come up with that value. So that all of these are types of data. What is statistics? In one sense, what we're learning as a course, as a field of study, it is a method or a science of analyzing and doing stuff with data. That's what statistics is. However, you will also see people who use the word statistics as for the data itself. They'll say, oh, here's the statistics. So they're not talking about the science, they're talking about the data. So you'll see that used interchangeably. Okay. When we talk about data, in the realm of doing statistics, there's two things we're trying to get. One thing is we're looking for a population, which is all the people we're interested in. Now, we might do a survey of a particular group of people, say high school students in the USA. That would be our population, would be all of them. But when we actually go about collecting the data, that's a lot of people to go talk to, right? So what we do is we take what's called a sample, and we come in and we take some of the people. This lady got chosen. This lady over here got chosen. And let's see, I think it's this guy here. So we sampled the group. Instead of talking to everybody, we said, let's just pick out a few of these people and let's get their opinion. And we'll see, and we'll analyze that because it's less stuff to work with. What we find is with the science of statistics, oftentimes this actually works better than going and asking everybody if you take a sample. And part of what we're going to do is there's different methods for choosing those people we're going to call our sample. How did we choose these people? Well, there's, again, multiple ways we could have done it. Could have asked for volunteers and stuff. We're going to see that there's specific ways that are sort of good ways to do it and other ways that are not so good, right? Because, had these all been females, we might have gotten more what we call bias, right? We get their opinion, but maybe we want a mixed opinion. So we'll be talking about that in in 1.2, the next section. But sample, So there's always this relationship. We're going to be talking about a population and a sample. So which one's bigger? Very good. That's how you do the populations. Everybody, samples just a little group out of it. That's the way, one of the ways to remember. All right. So here's a statement. We'll read over it. Identify what's the population, what's the sample. So a recent survey, 834 employees in the United States were asked if they thought their jobs were highly stressful. Of the 834 respondents, 517 said yes. Identify the population in the sample. So what would be the population in this case? 834 what? So is there only 834 employees in the US? So that must be a subgroup, right, of all the employees. So this is a tricky one. That's exactly when I did this morning. That's what I thought. Oh, I thought that's 817 is a smaller number, or 517, 834, but actually, all the employees in the U.S. all our population. We want to know about them. The sample was the 834 of those employees that we chose. So this 834 is actually the sample, and they'll be on the next slide too. And the 517 are like data, the responses, right? They said, yes, it is stressful. So how many didn't say it? Well, you could subtract off and you would assume everybody else said no, but that's not a good assumption to make, because sometimes, have you taken a survey where you didn't answer the question? I have. None of your business, right? So, but 517 said yes. So that's how we would look at that. So the sample is the 834 employees, but the population would be so always think the population is going to be sort of usually a bigger group. It's a group we didn't ask everybody, but only part of it. And then we've got a subset, and they did the math for us. So yeah, 517 said yes. They subtracted and said 317 must have said no. So those are part of the data sets. Good. Good way to think through that. Make sense? So population or sample is part of the population. So now whenever we're talking about statistics, we have to mention those two groups. A lot of times the statistics or the analysis we do is on the sample, but we want to relate it back to the population. So the population, it has something called, when we're looking at the population, we have a parameter that we want to know something about. In that last survey, the parameter was, are you satisfied with your job, yes or no? That's the parameter, because we want to know that for the whole population. So we call that the parameter. Okay, so the parameter deals with the population. The sample, those people who did say yes, the 517, that's a statistic, right? So it's the same thing. It's that numerical description of what we're trying to get at. Is your job stressful or not? That's the parameter. The statistics was 517 said yes, 317 said no, right? So the statistic always deals with the sample. So S goes with S, P goes with P. Kind of, so as you go through homework, you'll have questions that will throw these at you. Is this a parameter or is it a statistic? Statistic always goes with a sample. Parameter always goes with the population. And they're related, they're very similar. But the parameter is what we're trying to find out. The statistic goes with the sample of what was the number that was associated with it. So far, so good? Okay. And those things in red, those are the vocabulary we're trying to get you to learn and understand. Okay. Not be able to write a definition of them, but be able to use them. Okay. So here's an example. In the United States, we had a survey of about 9,400 individuals aged 15 and over, and found that each such individual spent an average of 5.19 hours per day engaged in leisure and sports activities. So on this one, what would be the parameter? What's that? United States. So that's kind of dealing with our population part of it. But what did we want to know about the people in the United States? There you go. You're getting onto it. The, the, the characteristic we want to know is how much time they're spending in leisure. So, uh, leisure and sports activities, this gives us what our parameter is. This is what we want to know. Then what would be the statistic? The five that usually your statistic's going to be a number, not always, but yes, it is that uh, this is how many hours that sample spent, right? Because we asked them, we didn't get everybody in the U.S. We got a sample, and from that sample, we were able to determine a statistic, a numerical measurement of leisure time. Okay, that makes sense. All right, very good. So you kind of see how this works, uh, and again, you'll get it. So the average of 15 is based on the subset of the population. It's a sample statistic. Okay, but in this, when we're given a statistic, we are also sort of given what the parameter is, because whatever they tell us what that was measuring. So we don't always have both, but we sometimes do. Now let's describe if this is a parameter or a sample statistic. Freshman class at a university has an average SAT math score of 514. That number 514, is that a parameter or is it a statistic? Why? Good. Exactly. It's right there. You said it's a sample. It's only the freshman class, right? Out of the whole university. Good. Because the SAT score method is based on the entire freshman class. Um, and again, this is sometimes, I would disagree with this um, because they're talking about a university. Uh, University doesn't have just freshmen, even though it is an entire freshman class. Unless that, again, you have to see how the study was set up. Maybe the study only wanted freshmen. Then I would go with what they're saying. I'm thinking the study wants to know what's going on at the university. Freshman class is a sample. So these are the types of things you can do. I would challenge that question and say, no, you guys don't know what you're talking about. That's a sample. I agree with you. Uh, and on a test, if you get something marked wrong and it's like that, come talk to me about it. Part of it is stickiness. I read it this way. Okay. So that, is it a sample or is it a population? It all depends on how the phrasing is. Okay. So I think I would go with us being right. Um, Another one, random check of several hundred retail stores and Food and Drug Administration found that 34% of the stores were not storing fish at the proper temperature. Is that it's a statistic. Now this is a little bit because we were told right here they checked several hundred retail stores, so they didn't say they checked them all. A little clearer, we could definitely say that's got to be um, a statistic because it's a sampling, just a few stores that they checked. Okay. So now we're getting to, again, another definition part. Let's see, how long do we have today? We go to 10:25? 10:55. Wow. Oh, that's right. We get okay. So I can relax. I don't have to rush so much. Okay. So we got a little extra time. Anyway, so again, definitions, descriptive statistics. So this is where we describe characteristics that are going on. And a lot of times this is where we have like pie charts and stuff. It's just to kind of collect the data and show what all the data is, to describe a group, a population. Well, usually it's a sample, but to help do it from just describing it. From those descriptive statistics, though, that's where we can oftentimes do some calculations to do some inferential statistics, which is from that sample, try to figure out what's going on in the population and sometimes predict what might happen to another group of a sample or something. So these students scored 517 on the SAT because they had the same teacher. Will the next group also score about 517? So we're trying to make some predictions generally with the inferential. Or, I asked 4 people what their opinion was. Can I take that and say that that's what the rest of the population would have as their sample, right? And that's hard to do sometimes, right? Because we got West Coast people, we got East Coast people, and that's, we have different opinions, and North and South, and so regional differences. So we have to have, and that's part of what we're going to do with statistics, is see ways that we can get the proper sample so that it represents everything we want to know and everything we want to do. So again, from the little group, from this sample, can we really talk about the population? If we can, then we did our statistics right. Okay, so let's talk about the difference. Is this a descriptive or an inferential? See, we'll do this. So we've got a study of 1,502 U.S. adults. They found that 18% of the adults from the households earning less than $30,000 annually do not use the internet, as shown in the figure. So we got a figure over here, and 18% earn less than $30,000, do not use the internet. Okay, so is that a descriptive statistic, or is it an inferential statistic? Descriptive. It's about that sample, and it's not saying that, it's not trying to make it sound like, well, then that means that 18% of the U.S. It's simply, 18 is talking about the sample. Good. Okay. Here, identify the population and the sample, and which part represents the descriptive branch. So a study of 1,000 U.S. 401k retirement plan participants found that the percentage who do not know how many years their retirement savings might last is 32%. Okay, so maybe a statistic there. What would be the population for this group? There we go, all of them, all of them. Where's the sample? The 1,000. The 32 would be a statistic from that sample, right? So those are connected. The 1,000 is a sample. That's who we asked. 32% of them said that they're not sure how long their money's going to last. Okay, and so it's a description. How could it be inferential? Okay, okay. Part of it, it does say a study of the 1,000. So it's a little hard, but that 32% must come from that study, so that from the 1,000 that they asked. If we then would imply that in the US, 32% don't know where they're coming from, that would make it inferential, right? We're saying that from those 1,000 people that we asked from our sample, we're making a statement that 30% of the whole US doesn't know how long their money's going to last. Okay. Good. And that's actually, again, on the other text, that finished up. So then what we're going to pick up now is the difference between qualitative and quantitative data. There's a difference in, they both start with Q, so it makes it a little confusing, but we're going to see how to focus on that. And then there's 4 different levels of measurement, 4 ways to measure data. And then, so we're going to put all of this together, and then we'll get you into some packets where you're going to take these same things. Since you don't have access to the Canvas course, we'll figure out the second part, and again, it may go into, and we don't meet on Thursday, right? Okay, so no Thursday, so we'll be back on Friday. They told me, did I mention this, that by the end of the week, we'd have you all in the course. So we'll have access. Hopefully that means by Friday. I'm hoping. So then Friday we can get you kind of up and running. So then we start next week all nice and fresh. Okay. Qualitative data. The thing we want to um, focus on, again, since they both are going to start with Q, is the L. This is the one with the L, quality. So it's the quality of something. It's a characteristic that is not numerical. It's not a number. Okay. So, what major are you studying? Math, science, English, psychology. So those are not numbers, those are categories. Where were you born? You don't give a number, you don't give a coordinates of where you were born, you give a city or a state or a country or something. So that's qualitative data. Eye color, brown, blue, mine are red right now, but that's whatever, so those are qualities. This is important data, but could we do any math with any of this stuff? Can you take brown plus red and get, no, it's, well, maybe if you're an artist, you could, right? But so this is, we actually can't do mathematics with it, but sometimes we'll get some things to deal with it. But qualitative data is important because it gives us these characteristics, but it's not what we're going to be doing calculations with, right? And then the other main type of data is the quantitative. Quantity, amount is what I like to think about. So quantity is an amount of stuff. And that would be things like, how old are you? That's a number. Weight of a letter, that's a number. It's a measurement, right? Temperature, a numerical value. You have to put units with it too, because there's that, it's 5 degrees out. Well, is that Celsius or is that Fahrenheit? It's different temperature, right? But it is a numerical value. One thing I like to ask about is there are types of data that are tricky. What about a phone number? Is that qualitative or quantitative? It varies on your location. And see, it's sometimes hard to tell. Did you say qualitative or quantitative? Good, the L. Because can you do math with a can you take my phone number and your phone number and add it together and get something that's no, you get and again, because of area codes, right? That gives you your region, your area. So there's information in there. They use numbers, but it's more of really a list or a label. You dial that number, you get that person. So phone numbers, even though they're numbers, they're not quantitative. They're qualitative. So yeah, see, this is always. I wish they would have choose 2 different words, like, and think of it. A phone number is not an amount. So that's the word I would use. Replace quantitative with amount, and you're going to get it right off. Qualitative with like characteristic or something. Okay. In addition to that, there's 2 types of quantitative data, 2 types of an amount data. And let's think of this. One is what we call discrete. And discrete means it has to be a particular value. So like if we're counting things, living beings, we can get 1, 2, 3, but you can't get half of a living being, right? You get either full, so those type of things are discrete. And some things you could get a half, like maybe a shoe size. You can get a 10 and a half. So you can get a 10, 10 and a half, and 11. But I haven't ever seen a shoe size that's a 10.25. Have you? It's you either get a 10 or 10 and a half, right? Or you get the 11. That's discrete. So it doesn't have to be an integer value, but it has to be only particular values. Okay, so that's going to be discrete data. If there's discrete data, the other type is continuous. Now, this type of data is typically when we're measuring something, and this can take on pretty much any value. Okay, because you could measure this, is this 12.2, or is it 12.26, or is it 12.265? And again, if we get down here with a microscope, we can get more and more accurate, but can we really exactly get it? Maybe not. So generally, measurements are going to be our continuous data. So it's not that, think of it as analog. It's, well, actually, I got a good example here. I forgot about this. Anyone else into music? I like music. So an example of discrete would be a fretted guitar. So you only get certain notes because you've got these frets that you put your finger down and that makes the note. And generally, you can put your finger anywhere in here and that's just going to play that note. Continuous is a fretless guitar because you can put your finger anywhere and you can get a lot more different sounds, which if you're good is great, but if you're a beginner, you probably want the fretted one because you only want those certain certain notes, right? So this is discrete. You only get so many notes. This is continuous. You can get any note along there and go up and along. Okay. And I played the violin when I was in middle school, and then I stopped playing for a while. So then I played the mandolin, which has frets because it's a lot easier. Violin was no frets, harder to do. Make sense though? Those two different types. So part of this, in this beginning, we're just saying, we're getting you to be able to identify things. Is it going to be is it qualitative or quantitative? And then if it is quantitative, is it discrete or is it continuous? Okay. So we'll go through some examples. How about this one? So this is a table. It shows sports-related head injuries for several sports. What part of this data is qualitative? The sports themselves, right? They're not numbers, right? Yeah, exactly. So the names of the sports, these are labels, these are qualitative data, right? And then what would be the quantitative data? How many head injuries there were. So quantitative over here, amounts. So sometimes we see tables and we get different types of data. Qualitative, quantitative. Perfect. Perfect. Now, this is where, and this is where we're going to stop today. So that's, it's going to be, or we're going to transition into the note part. And you'll have a listing of all of these. So that's why I'm not having you take notes. All of these are going to be on the sheets that you get. So you're going to have those, and those you can keep and you can use while you're doing homework, everything. So, so now we're going to talk about 4 different levels of measurement for data. Okay. The first is these, and again, sometimes I mix them up, but the nominal level is simply something, it's only applies to qualitative data, so no numbers. And so that's how you can identify if we're at the nominal level. We've got something that's qualitative, right? It's got to be this one. It's something that gets categorized using names, labels, or qualities. So that last one, the sports, that was, not only was it qualitative, it was at the nominal level. And we cannot do any mathematical computations. So that's nominal. There's another type of measurement, data, the ordinal level. Again, we've got to distinguish through. This can actually, the ordinal level can be qualitative or quantitative. Typically, what we're going to see, it will be qualitative data, but what makes it different is it can be done, it can be put in order or ranked. Now that last one with the sports, football, baseball, softball, whatever, you can't really put them in any particular order, right? But with something that's ordinal, it could be qualitative, but there might be an ordering for it. Like it might be a first, second, third. Sometimes maybe how it's done. Okay, but that's the key part. It can be, but doing math with it is not meaningful. So differences, if you subtract the two, it doesn't really give us anything of value. So we're not really, even though it could be quantitative, doing math with it is not going to be of value. So these are the first 2 types. And then we're going to deal with 2 types where the math is important. So here we go. Here's 2 different types of data. One is movie genres. The other is the top 5 occupations with the most job growth. One of these is nominal. One of these is ordinal. Which one is which? 2 is what? Nominal? Yeah, because could you put those in any particular order? Well, maybe you could, because which by what you like. But yeah, we could list them in any list, right? We could move the horror movies to the top or put it in the middle. There is no implied ordering. How about number 1? That would be our ordinal, and it's got an order only because they gave it an order, right? So they had to collect some data, and that's the top 5. So it's qualitative data, right? Home health and personal care, that's a qualitative data, but it happens also to be the first of importance, or uh, of the most quickly growing job category. So we've got an ordering here, so now it's ordinal data, not just nominal. Okay, um, good. And the thing is as we get further on, we'll be doing graphs and stuff, and if you've got ordinal data, you can actually use certain types of graphs, and it has an importance because there's this ordering that that wouldn't necessarily make sense with nominal data. So there's our solution, ordinal, and nominal. So you guys are right on, right on. And again, you'll do a little bit more of this. The other 2 levels, so we've got 4 in total, these will deal with strictly quantitative data. So this is dealing with numbers. So there's 2 kinds. One is the interval level, and the other is the ratio level. Okay, and so for the interval level, we can order the data. Again, because it's numerical, it's quantitative, you can put it from smallest to largest. When you subtract 2 pieces of data, there is it's a value. You can maybe say one is this much bigger than the other, so it does have some value. And if you get a 0, it represents a position on a scale. So it doesn't necessarily mean none, but it could be, because you could actually, with interval level, you could have negative values for particular things. How much money did you earn last year? Well, maybe you lost money, so that would be a negative value. So the 0 is just kind of part of the scale, okay, with interval. And we'll look at some examples. Sometimes it's a little difficult, but that's what we'll do, is we'll just look at examples and say, is it interval or is it ratio? And again, these are a little bit, because they're closer in likeness, sometimes these are the ones we mix up. So ratio level is similar to interval level. It has all its qualities. You can actually subtract the values and it gets something of interest. But in this case, a 0 implies that there is nothing. So ratio level measurements, 0 sort of, we don't have any of it. So it's kind of more for counting things or measuring things. We wouldn't necessarily have a negative. With ratio level, you can actually take a ratio. You can take one divided by the other, say that's 50% larger or something, and it has meaning. Okay, so you can do the ratio, and that allows you to say maybe 1 is 3 times as big, 4 times as big, so you can compare data values with multiples. You can't do that with interval. Okay, and again, we'll look at some examples, but these are always, for me, the ones that sometimes I get them right and sometimes I get them wrong, and sometimes you're close, but that's okay. It's just kind of working through it. And when you're doing statistics, it's what we want you to just kind of have this understanding that there are these 2 different types, so that you don't start trying to do, if you've got interval data, you don't want to be taking ratios with them, because it's meaningless, right? And oh, I forgot to delete this because I made it smaller. So here's some numbers, 2 sets of data. The New York Yankees World Series victories all these years. And then we've got over here, we've got the American League home run totals by team. Which one of these is interval? Which one is ratio? And why? Why? Exactly. Twice as much. You got it. Exactly for that reason. And we could divide them and say, okay, they got twice as many or 3 times as many, and that would make sense. Would that make sense with the year? I could take 1923 divided by 1927. Does that give me anything of value? Nah. I could subtract them and say it took them 4 years to get the next one. That's kind of, so that this one here would be the interval level, right? We can't subtract the values, and then it makes difference. Or you could say take 1923 minus 2009, and that's how many years between the first time and the last time, right? So that has some value. So we can't subtract them, but we can't take a ratio. Not really. So this is our interval data. Okay, makes sense? And there's our solution, interval level, ratio level, just like you all picked. And so here's just a summary, and we're almost done with this lesson. So can you put data in categories? With all of them, you can actually put them into categories, like years and stuff, and you can still categorize them. Even the one with the Yankees, we could put them into categories of in the 1920s, the 1930s, so you could break them up into different categories as well. Can you arrange the data in order? Well, all of them you can, except for nominal. Nominal is just strictly qualitative labels, names. Can't put them in order. Now, let's get with this. How about our names? That's qualitative data, right? It's not a number. Would that be nominal or ordinal? You could look at it nominal, but because, well, we don't have it here, but in grade school, what do we have at the top? A, B, C, D, E, F, G. So there is actually an ordering of letters, right? So we could choose to put our names in alphabetical order. Then it would come from nominal to being ordinal. Okay. So again, it's how do you want to do it? Now, in typical, just because my name starts with a Z doesn't mean I'm the last person on the list unless it's been put in alphabetical order. So we can go back and forth. Can you subtract data values? Nominal and ordinal, no, because they're mostly qualitative data. And again, that was one of the characteristics. But in interval and ratio, you can subtract them and get something of value. And then finally, the last one, can you get multiples? The only one that fits that is ratio. And it's in its name. Ratio just means fraction. So you can divide them, get multiples, and that's it. Okay. And then there's just some examples in here. And again, when you have access to Canvas, you'll also have access to these slides. You'll just click on them and you'll get there. Again, I'm recording this. I post them to my YouTube channel, and then it accesses that. So you'll have access to the recording as well. Anyone who wasn't here today will have access to what we've been doing in class, and so forth. But think about it. Motion picture, your rating is a non-numerical value, but there is sort of an implied ordering of it from who can watch those movies. And as you go up the scale, younger people are not supposed to be watching these ones here. We get to an NC-17, only people older than 17, 17 and over, I guess, can watch those type. So again, qualitative data, but it has an order. Okay. Here's some interval with dates. So you'll see those ratio. Again, average, this is average rainfall. And again, you could divide them and say, well, there was twice as much rain in, see, what month is that? That is June compared to March. So June had twice as much rain as March did. And you can do that with a ratio calculation. Okay, and then now we're going to get you the packets, and these I think we'll take you all the way through chapter 1, and these are yours to keep and use. And when we go to the quizzes, you can refer back to these. I'll give you those two, and then I'll give you those two. Okay. Yeah.
So if you can give them the link right now, they have the Chrome.
Okay.
On it and actually read it.
Yes.
You're trying to struggle with it, so they can read it and be ready.
Thank you. Now I just got to figure where I'm going to put it.
Well, you can send it to me, and I have a Google Classroom set up for them. And
perfect. Perfect. Let's